students, myself Dr. Bharti Patil, working as an assistant professor physics in Maharaja Jivajirao Shinde College, Srigonda, Ahmednagar. We have started our syllabus related to solid state physics related to our TYBSc class, and in that we have started chapter number 1, the crystalline state. During learning this chapter, the crystalline state, we have to cover few of the points related to few of the crystal structures such as NaCl, that is sodium chloride crystal structure, ZnS crystal structure, diamond crystal structure, hexagonal fluorspar and cesium chloride crystal structure. One by one we will see what are these. So in today's lecture I am going to cover the point related to NaCl crystal structure. NaCl, it is also called as rock salt. NaCl is nothing but the sodium chloride. If we see the atomic number of sodium, then it is 11, and atomic number of chlorine, it is 17. So electronic configuration of sodium shows that there is one atom at the outermost shell, and in case of chlorine there are 7 electrons in the outermost shell. In case of NaCl, electronic configuration of Na shows that there is 1 electron in the outermost shell of Na and 7 electrons in the outermost shell of Cl. Therefore, when we see the NaCl crystal structure, it forms the ionic bond. So, it is an ionic type of crystal. This figure shows the NaCl, that is sodium chloride crystal structure, and here the chlorine atoms are represented by black colored spots, whereas the sodium ions are represented by hollow circles. I will explain this crystal structure to you. If we consider NaCl, then if we consider or compare the atomic radii of sodium and atomic radius of chlorine, then it is seen that the chlorine ionic radius is more as compared to the sodium. So, the chlorine atoms or the chlorine ions occupy the corner positions of the cube, and the sodium ions occupy the octahedral voids. I will explain this to you. So, if we see the crystal structure of NaCl, then it is of face-centered cubic type, and the basis consists of, what is basis? We know that in case of crystal structure, there is a regular periodic arrangement of points in a space. It is called as lattice points. These are called as lattice points. Then at each lattice points, we have to locate the atoms or the molecules. And if in case of NaCl, we are placing the Na ion and chlorine ion at the lattice points, and these are nothing but the bases. It means that the bases consist of one Na plus ion and one chlorine ion, and they are separated by 1/2 the body diagonal of unit cube. So, chlorine ion is separated from Na ion by 1/2 of the body diagonal. Therefore, it may be considered as there are two face-centered cubic lattices, and the sub-lattices consist of one Na plus ion and other of chlorine ion. And the unit cell of sodium chloride structure consists of 4 molecules of NaCl in each unit cube with ions in position as shown below. Just now I have explained you, as the atomic radii of chlorine ion is greater as compared to sodium ions, they are occupying the corner positions and also the face centered positions, whereas the Na plus ions, which are nothing but the cations, they are occupying the octahedral void spaces, and they are separated by half of the body diagonal. Therefore, if I represent chlorine ion at 0, 0, 0 position, then Na plus will be situated at half, half, half position. So, NaCl is AB type of crystal structure. Hence, we have concluded that NaCl is a AB type of crystal structure. It means that it consists of two types of ions, A and B. And Na is nothing but the cation and chlorine is nothing but the anion. And cation to anion ratio in case of NaCl is 1:1, that is Na:2Cl ratio is 1:1. Just now I have explained you that size of chlorine ion is large as compared to Na plus ion. Chlorine ions are present at the corners and at the center of each face. Hence, suppose I want to find out the number of chlorine atoms per unit cell. Chlorine atoms, or consider chlorine ions per unit cell, then we know that there are 8 corners for a cube and each corner atom is a part of 8 unit cells. Therefore, its contribution to the present unit cell comes out as 1/8, and there are 8 such corner atoms. Therefore, the number of chlorine ions per unit cell is equal to 1/8 into 8 is equal to 1. It means that due to corner atoms, there will be only one chlorine ion or atom due to the contribution of the corner atoms. I have also explained you that the chlorine ions are also occupying the face centered position. We know that the face centered position is the part of 2 unit cell. It means that its contribution to the present unit cell comes out as half, and there are total 6 such face centered atoms or ions present. Therefore, the contribution due to face-centered chlorine ions comes out as half into 6 is equal to 3. It means that the contribution due to the corner atom comes out as 1 plus contribution due to the face-centered atoms comes out as 3. Therefore, we can conclude that in case of NaCl crystal structure, there are 4 chlorine ions are present. Now let's see the number of Na plus ions. So Na plus ions are present at the octahedral voids. We know that in case of face-centered cubic lattices, there are two types of voids, octahedral voids and the tetrahedral voids. The octahedral voids are present at one at the center of unit cell and 12 at the midpoints of 12 cube edges. We know that cube has 12 edges, and at the center of each cube edge there will be presence of one Na plus ion, and one is located at the center of the cube. So we know that if I want to calculate the number of sodium ions or atoms present per unit cell, then I have to consider the contribution due to the center atom, which is 1 because it is not at all shared by anyone, and the contribution due to the atoms which are present at the midpoints of the edges. It comes out as 3 because each edge-centered atom is shared by 4 unit cells. Therefore, the contribution due to the each edge-centered atom comes out as 1/4, and there are 12 such edges. So 12 into 1 4 comes out as 3. Therefore 1 due to the center atom and 3 due to the midpoints of the 12 cube edges. Therefore the total number of Na plus ions comes out as 4. In this structure, each ion is surrounded by 6 nearest neighbors of opposite kind. It means that we know that what is the coordination number? Coordination number is nothing but the number of nearest neighboring atoms, and they should be equidistant. So equidistant nearest neighboring atoms. Therefore, in case of NaCl, if I consider the Na ion, then it is surrounded by 4 chlorine atoms or ions in its plane, one above the plane and one below the plane. Therefore, there are total 6 opposite kind of atoms or ions surrounding the Na, and same is the case in case of chlorine ions or atoms. So the coordination number comes out as 6, and if we want to see the such type of NaCl type of crystal structures, then such type of crystal structure is present in case of KCl, that is potassium chloride, LiH, then KBr, PbS, that is KBr, potassium bromide, magnesium oxide and barium oxide. These are few of the examples of the crystals who shows the crystal structure like NaCl. So let's revise today's lecture. Once again, we have seen the crystal structure of sodium chloride. We know that it is a type of ionic crystal, and NaCl crystal structure, Na ionic radius is less as compared to chlorine. So chlorine acquires the position of the corner and at the face center, and Na ions are occupying the position at the octahedral voids. Then it forms a face-centered cubic lattice. Bases consist of one Na plus ion and one chlorine minus ion, and they are separated by half of the body diagonal of the unit cube. It may be considered as two face-centered cubic sublattices. One is made up of Na plus ion and other is made up of chlorine ion. And if we consider the total unit cell, then there are 4 molecules of NaCl in each unit cell. Then it forms AB type of crystal structure if Na is the cation and chlorine is anion. Cation to anion ratio is 1:1, and if I want to calculate the number of chlorine atoms per unit cell, then chlorine contribution due to the corner atoms comes out as 1, and the contribution due to the face centered atoms comes out as 3, and hence number of chlorine atoms or chlorine ions present in NaCl crystal structure comes out as 1 plus 3 is equal to 4. Now, just now I have explained you that Na plus ions are acquiring the position at the octahedral voids, 1 at the center of unit cell and 12 at the midpoints of 12 cube edges. Therefore, the central Na plus ion is not at all shared by anything, so its contribution is 1, and the atoms or ions which are located at the midpoints of the 12 cube edges, they are shared by 4 other unit cells. Therefore, their contribution comes out as 12 into 1/4, that is 3, and hence the total number of Na plus ions present in NaCl crystal structure comes out as 1 plus 3 is equal to 4. It means that NaCl crystal structure consists of 4 ions of chlorine and 4 ions of Na plus, that is 4 molecules of NaCl are present in a unit cell. And if I want to calculate the coordination number, then coordination number is nothing but the number of equidistant nearest neighboring atoms. If I consider the Na plus ion, then it is surrounded by 6 equidistant chlorine ions, and if I consider the chlorine ion, it is surrounded by 6 Na plus ions. So the coordination number is 6. Other examples of NaCl type crystal structure are KCl, LiH, KBr, PbS, MgO and BiO, that is potassium chloride, potassium bromide, lead sulfide, magnesium oxide, barium oxide. These are the materials which are showing the NaCl type crystal structure. Hope you have understood the today's lecture. Thank you.